Alright, so in this problem we're going to be looking for the solubility of lead-2 fluoride in grams per liter, how many grams of it will dissolve in a liter of water, given that we know the KSP of lead-2 fluoride. So in order to do this, first thing we have to do is figure out what lead-2 fluoride is. So remember, lead-2 means Pb2+, and fluoride has a charge of 1-, so we're dealing with PbF2. Okay, and therefore we need to also figure out what's going to happen in solution, because if this is a solid, we put into solution, some of it will break into ions, so we'll make Pb2+ and 2F-. Okay, there's our reaction. Okay, the other thing we're going to look at therefore is what's going to be the KSP. Well, our KSP is going to equal concentration of Pb2+ at equilibrium times the concentration of F- at equilibrium, and that is squared. Okay, so now we can see that that's the equation for KSP. If we can find what fits inside of it, we can go ahead and solve for x. So I'm going to set up a Rice chart, and PbF2 being a solid doesn't really matter. We don't need to worry about that. And Pb2+, okay, we're going to assume that we're initially just adding this to water. We want to know how much of it's going to dissolve, so change, we're going to have plus x and plus 2x, and therefore at equilibrium we're going to have x and 2x. Alright, so now I've got this all set up. Now I can look in and sub these in for my KSP. Say that my KSP is going to be equal to x times 2x squared. So that means that 3.3 times 10 to the negative 8th is equal to x times 4x squared, so 4x cubed. Divide that by 4, take the cube root of it, and we'll get that x is equal to 2.02 times 10 to the negative third. Okay, and so now we want to know the molar solubility of this. Well, this is how much dissolves, right? Because for every x of PbF2, that's how much Pb2+ goes into solution. So we're simply going to say, all right, we can get 2.02 times 10 to the negative third moles per liter of Pb2+ to dissolve, and there is 1 mole of PbF2 for every 1 mole Pb2+. So now we've got moles of PbF2 per liter, and I want to go to grams, so all I'm going to do is multiply by grams per mole, and if you add it up you come to 245.2 grams per 1 mole of PbF2. Do that out, and you get 4.95, and therefore what we're going to have is, by rounding to sig figs, 5.0 grams per liter. So that right there is the molar solubility. You can get the solubility in terms of grams per liter of lead-2 fluoride. You can get 5 grams to dissolve in 1 liter of water. And therefore, if the problem asked what's the minimum mass of lead-2 fluoride you needed to add, you would simply say, oh, we need to add 5 grams to 1 liter of water in order to make a saturated solution.